Welcome back to James's Physics 101. Today, we explore the inevitable destiny of our very own star, the Sun. In this lesson, we will trace the journey from the end of the main sequence through the red giant phase and finally to the Sun's quiet retirement as a white dwarf. For billions of years, our Sun has been a stable companion. But stars, like all things, change. When the hydrogen in its core runs out, a dramatic transformation begins, one that will reshape our entire solar system. It starts with a crisis of fuel. As hydrogen fusion slows in the core, the outward radiation pressure drops. Gravity, the patient sculptor of the cosmos, finally wins the battle and begins to crush the core inward. This contraction increases the core's temperature and pressure to staggering levels. Meanwhile, a shell of hydrogen around the core begins to fuse, releasing a massive burst of energy that pushes the star's outer layers outward. The Sun will expand into a red giant, growing so large that it will likely engulf Mercury, Venus, and perhaps even Earth. Its surface will cool and redden, but its total luminosity will skyrocket. Deep inside this giant, the core continues to heat up. When it reaches 100 million Kelvin, helium nuclei begin to fuse into carbon in a sudden, violent event known as the helium flash. This stabilizes the star, but only for a time. Eventually, the outer layers are cast off into space, creating a glowing shroud called a planetary nebula. These cosmic tapestries are the discarded garments of dying stars, enriching the galaxy with new elements. What remains is the hot, dense core of the original star. It is no longer fusing atoms. It is simply a glowing ember, cooling over trillions of years. We call this a white dwarf. White dwarfs are incredibly dense. 1 teaspoon of its material would weigh 5 tons. They are held up not by fusion, but by a quantum effect called electron degeneracy pressure. There is a limit to how massive a white dwarf can be, 1.4 times the mass of our Sun. This is the Chandrasekhar limit. Beyond this, gravity overcomes even the quantum pressure, leading to a much more violent end. But for our Sun, the journey ends here. It will slowly fade into a black dwarf, a cold, dark remnant of a once mighty star, leaving behind a solar system that is vastly different from the one we know today. To recap, stars like our Sun expand into red giants when they run out of hydrogen, shed their layers to form planetary nebulas, and finally settle as dense, Earth-sized white dwarfs. Thanks for joining us for Lesson 4 of Astrophysics in 10 Micro Lessons. Next time, we witness the violent deaths of massive stars in supernovas. Stay curious.